Okay, so this is a good example of an empirical formula question, AP Chemistry style. So what we need to do is we need to find the empirical formula of this compound CXHYNZ. We don't know any of those subscripts. Here's what we do know. It says if we combust 35 milligrams of this compound, we get 33.5 milligrams of CO2 and 41.1 milligrams of H2O. A couple things we want to know in advance. We know that H2O is 89% oxygen by mass and 11% hydrogen by mass. We also know that if we are looking for the percent composition, for example, of CO2, we know that the carbon is 27.3% by mass and the oxygen is, hang on, doing this quick on the calculator, 72.7% by mass. Okay, let's keep that information handy. What we know that when we combust this product, it means combining it with oxygen, and the products are CO2 and H2O. Here's what we know. We know, for example, that when it produces 41.1 milligrams of H2O, that 41.1 milligrams is 89% oxygen. We also know that the 41.1 milligrams is 11% hydrogen. Well, that hydrogen has to have come from here. So what we're going to do is we're going to say, and first let's get that into grams because that's a lot easier to work with. 41.1 milligrams is equal to 0.0411 grams of H2O. And if we know that that water is 11% hydrogen, we're going to ask, well, if our 0.0411 grams of water is 11% hydrogen, 0.11, what mass of that is hydrogen? So we're going to say 0.0411 times 0.11, and this tells us that the hydrogen that came from this compound was 0.004521. So we know the mass of hydrogen in this compound. Let's do the same thing with our carbon. We're not worried about the oxygen because the compound doesn't contain any oxygen, but what we can do is we can find out how much carbon we have. We know that the carbon dioxide produces 33.5 milligrams or 0.0335 grams. Well, what percentage of that is carbon, if the mass percentage of carbon dioxide is 27.3% carbon. So what we're going to do is we're going to say, all right, we've got 33.5 milligrams, 0.0335 grams, and the carbon is 27.3%, so 0.273. And I should be using this calculator. I shouldn't be a doofus. It's just slower, you know. We'll say 0.0335 times 0.273 is 0.0091455 grams. I'm expressing it to as many decimal places as I can. 1455. Okay, we're coming into this with some advantages. We know that of this unknown compound, it is a total mass of 35 milligrams or 0.035 grams. And we know that 0.0045 grams of that is hydrogen and 0.009145, whatever, grams of that is carbon. Let's leave all of these things in grams and find out what mass of nitrogen we're talking about, because we know the hydrogen, we know the carbon. So we're going to say 0.035 grams total. From this, we're going to subtract, I don't need that yet, the mass of the hydrogen, 0.00451. And we're going to subtract from this the mass of the carbon, 0.0091455. This is going to tell us how many grams of nitrogen we're talking about. So let's do it on the calculator. And we'll say, let me clear this, 0.035 grams minus 0.004521 minus 0.00911455. Here's how much hydrogen, or nitrogen we're talking about. Oh, I got rid of that too quick. 0.0213335. 0.0213335 grams of nitrogen. Okay, everybody, we've got a mass of hydrogen, we've got a mass of carbon, we've got a mass of nitrogen. Let's do what we used to do back in the day and find moles. How many moles of hydrogen are we talking about? If we have 0.004521 grams of hydrogen, 0.004521 grams of hydrogen, you'll probably find your answers work a little bit better if you use the true molar masses. So let's find out how many moles of hydrogen this is. So we're going to say 0.004521 divided by 1.0079. This is 0.0044855. 0.0044855 moles of hydrogen. Do the same thing with oxygen. We had, or carbon, excuse me, 0.0091455 grams of carbon. How many moles of carbon is 0.0091455? 0.0091455 grams of carbon. If we know that there are 12.011 grams of carbon in 1 mole of carbon. So, bust out our calculator. 0.009145 divided by 12.011 is 7.6 times 10 to the negative 4. Should I express that to some more decimal places? 7.61427 times 10 to the negative 4. And finally, if we know how many grams of nitrogen we have, how many moles are we talking about? If we have 0.0213335 grams of nitrogen and the molar mass of nitrogen, I got a periodic table right here from something else that we were doing right here. And nitrogen has a molar mass of 14.007. So let's do that. 14.007 grams in 1 mole. On our calculator, this is 0.02133335 divided by 14.007. 0.001523 moles of nitrogen. Okay, let's do it like we used to do it in first year chemistry. Divide everything by the smallest mole. Well, that's clearly oxygen, 7.61427 times 10 to the negative 4. And of course, that's 1. Let's do the same thing with the rest of these. 7.61427 times 10 to the negative 4. What do we get? 0.00153 divided by 7.61427 times 10 to the negative 4. And we get 2. Let's do the same thing with our hydrogen. And we're going to say 0.0044855 divided by 7.61427 times 10 to the negative 4. What we get? 5.89. That's close enough. We're going to call that 6. Remember, there's some variances in here. So what we get is our formula C, X, H, Y, and Z. The C is 1. I wrote that as oxygen. It shouldn't have been oxygen. It should have been carbon. C1, H6, and 2, or CH6 and 2. And that's all you do. Enjoy.